students, yes, I know you're excited about this. Yes, we have another day of word problems. You probably woke up this morning and said, I can't wait to get to Algebra 2 class to study more word problems. I'm sure that's true. So because of your excitement, let's get started. Your heading today is Chapter 2, Word Problems, Part 2. I would encourage you to always write down today's date so that you have nice organized notes. Your heading is Chapter 2 Word Problems, Part 2. Remember, tomorrow we have Part 3, and then we'll be finished with Chapter 2. These word problems today will deal with writing linear equations and inequalities. Personally, I feel like these problems are more difficult than yesterday, but you might disagree, so we'll see. Okay, here we go. We're going to do exactly like we did yesterday. We're going to look at two problems, so this will be a very short video, and I want you spending much of your time working on your homework. It's so important that you do that, okay? Alright, here we go. I would encourage you in your notes to write down page 89 and go ahead and turn in your books if you want to page 89. However, I would not take time and copy down this entire problem. I would not do that, okay? Just put page 89 and turn over there in your books, and that way in your notes you will know where we got this problem. In fact, I would write page 89, example 5. That's what I would write in your notes right there, okay? In 1970, there were 130 African American women held office. By 1990, this number had increased to 1,950. Write a linear model for the number n of African American women who held office between 1970 and 1990. T equals 0 represents 1970. Okay, now let's just step back and take a deep breath. We are going to write a linear equation or a linear model, exact same thing. Now, think about it. In the past, you know you have to have either two ordered pairs to write a linear equation, or you must have an ordered pair and a slope, or you must have the y-intercept and the slope. Okay? You must have something like that so that you can write the linear equation. That should make sense, students. Think about it. If you're going to write a linear equation, you must have some information about the line, and that's what we're trying to do. We're trying to write a linear model or a linear equation. Well, as I think about it, I do see a couple ordered pairs. I see in 1970, there were 130 African American women that held office in America. That's an ordered pair. Now, before we go any further, you might ask yourself, or you might ask Mr. Harris, why would you put the 1970 first? Maybe it should be the other way. Well, think about it, guys. Really think about this. This is usually your what number? X. This is usually your what? Y. Which one of these numbers do we usually put in first? Do we usually put a number in for X and get out a Y? Or do we usually put a number in for Y and get out a X? Well, if you don't know, let me help you. We usually put a number in for X and get out a Y. Now think about it. Are we trying to find a model in which we can put in time and get out the number, the estimated number of African American women in office? Or are you going to put in a certain number of women in office and get out a year? To me, it's pretty obvious. We want to have an equation where we put in a year and we get out how many women, African American women, held office in that year. Okay, so that's why I'm putting my two numbers in that order. Now, next, another ordered pair I see is 1990. We had 1,950. Now, I've got a couple ordered pairs. This is looking really good, but I have a problem. I do not want to use 1970, nor do I want to use 1990. How do you know that, Mr. Earhart? This right here. T equals 0 represents 1970. So for 1970, I'm going to use 0. So I'm going to put 0, comma 1930. Now think about it. If 0 represents 1970, then 10 years later that would equal 1980. Then 10 years later that would equal 1990. So what number am I going to use for 1990? 20. Okay, so I'm going to quickly get rid of this here. I don't need this. And we're going to put a 20 in there, okay? finally have my two ordered pairs. Okay, so if I have two ordered pairs, you guys should know by now what model do I use when it comes to writing a linear equation. This model here, correct? So I have to find the slope real quick. So my slope would be y minus y, 130 minus 1950. X minus x, 0 minus 20. So I would get 1950 minus 130 would be 1820. And 0, a negative 1820, and 0, negative 20 is negative 20. Now a negative over a negative is positive. 1820 divided by 20 would give me 91. So my slope is a positive 91. So there's my slope. So let's review for just a second. All that I had to do was find a couple ordered pairs that would help me write my linear equation. That's all I had to do. And I found that. Here's my two ordered pairs. I found the slope. And now I'm ready to write my linear equation. So it doesn't matter which ordered pair you use. I'm going to use this one here because it has a 0 in it. X, y. So y minus my y, 130, equals m, which is 91, times x minus my 0. So y negative 130 equals 91 times x, 91x. 91 times 0 is negative 0. Bring the 130 over and make it positive. So y equals 91x, positive 130. Alright, now, normally I'd be finished, but I'm going to be really, really tough on you guys. I want you to write equations or models that are really sound, okay? Look back up here and see if they gave us other variables to use besides x and y. You're going to see they did right here. Write a linear model for the number n of African American women. Well, this is my African American women, so this would be an n. So really, instead of using y, I should have used n. What else they tell us? Here it is. T equals 0 represents 1970. So my time right here, 0, is represented by t. So x should really be represented by t. So Mr. Earhart, why did you not tell us that at the beginning? Guys, are you kidding? I don't want to try to write a model like this. N minus n subscript 1 equals m. T minus t. That would have confused you guys so badly. So what we do is we just leave our model alone, which is y minus y, m, x minus x. Okay, we leave our model alone. We write the equation, and then when we're all done writing our equation, then we very simply make our substitution. For x, you should have a t, so don't have an x right here. Instead, for your x, we're going to put a t, and then for your y right here, here's your y, we're going to put an n. And there it is, we're finished. Alright, and that is the right answer. I will be strict on you guys. I will take off points on a test or a quiz if you do not put the appropriate variables in your equation, okay? Alright, last one. In your notes, I would write down page 96, example number 4, okay? Now, when you go diving, and I'm not an experienced diver, but I know this to be true, if you go down to a low, and actually you can read about this, if you look at the top of page 96, you can read about this, top of page 96 on the left. And what you will read about is this: the bends or decompression sickness is caused by rapid decrease in pressure. In other words, you're down really low in the water, there's a lot of pressure on you, then you shoot up too quickly, and that's called rapid decompression. You're getting the pressure off of you too quickly. What happens is nitrogen bubbles form in body tissue and bloodstreams. It's called the bends, and it hurts your blood circulation. You can actually die from this. And to avoid the bends, scuba divers must carefully monitor the time they remain at certain depths. Okay, so here are the models right here. Okay, the time t in minutes that a scuba diver can remain at a depth d in water without having to decompress. Now, I'm not sure, but I think decompress means okay? Well, you don't always have to decompress, okay? If you remain at a low depth in the water for a short amount of time, then you will not have to decompress. You can safely shoot right up to the top and you'll be okay. So here's the models that help us, okay? What they're saying is this: if you went down between 60 to 90 feet, you can put in that number. Let's say you went down 70 feet, okay? So where D is right here, you put what? 70. What's 120 minus 70? 50. So as long as you did not stay at 70 feet for more than 50 minutes, you would be fine. You could shoot right up and not have any problems. But if you stayed at 70 feet for over 50 minutes, then you're going to have to decompress, coming up very slowly. Let me show you another example. This model here is for 90 to 130 feet. So let's say you stayed down at 120 feet, okay? So for D right here, you put 120. Now, 1/2 times 120 is 60. 75 minus 60 is 15. So at 120 feet, the most you can stay there is 15 minutes. If you stay longer than 15 and 120 feet is way down there, okay? It's a lot of pressure, so you can't stay there that long. If you stay for about 15 minutes or less, no problem. You can shoot right up to the surface and you'll be fine. However, if you stay for over 15 minutes, then you have to go up very slowly and decompress. And you have to make sure you have enough oxygen in your oxygen tanks to come up slowly. Okay, so that's what these models do for you. Now, sketch the graph of these inequalities. Does a diver, and I'm not going to worry about sketching these graphs. We've done a lot of those today. I'm not going to worry about that. I want to get to the, well, actually, we're going to do a lot of these in our homework, I should say. I'm going to go ahead and sketch the graph after all. I think that'd be a good idea to do. So, very quickly here, I'm going to sketch the graph. I'm going to put in 60 to 90. So for this graph right here, I'm going to make a table of values. I'm going to put in 60 and 90. That'll give me a straight line because my two starting and ending numbers are 60 and 90. So put a 60 and you get out of 60. Put in a 90 and you get out of 30. Alright, so I'll go to another page here. We'll go by tens, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 60, 60 is one ordered pair, and 90, 30 is another. So over 60, 70, 80, 90, and up 3. So there's the one graph right there. Okay, now let's test. Now here's what we're going to do. Sorry about that. Now here's what we're going to do. Notice we have an inequality right here. We have an inequality, so we're going to test a point. And my favorite point to test is 0, 0. So I'm going to test 0, 0 and see if I get out a true or false statement. So put a 0 here and put a 0 here. 120 minus 0 is 120. 0 is less than 120. That is totally true. So I know I'm going to shade downward. Now, please don't shade yet. Please don't do that. Okay, just put arrows. Just put arrows showing the direction you would shade. We'll worry about the shading later, okay? Now, let's take a look at the other boundaries I have here, okay? Now I'm going to make my table of values for this function here range from 90 to what? 130. So 90 to 130, alright? So put 90 in for D. 1/2 times 90 is 45. 75 minus 45 is 30. Now put 130 in for D. 1/2 times 130 is 65. So 75 minus 65 is 10. So my first ordered pair is 90, 30. Which I think was the other ordered pair for the other one. Yes, it was. So I go over 90 and up 30. There's the ordered pair. It's 90, 30. And my other ordered pair is 130, 10. So over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 130 and up 10 right here. So that graph would kind of change directions a little bit and go like that. Now, if we test 0, 0 on this right here, we will get out a true statement. Put a 0 here. Put a 0 here. 1 half times 0 is 0. 75 minus 0 is 75. 0 is less than 0. So if 0 is less than 0, if 0 is less than 75, then yes, that's true. So I would also shade downward for this one too. So I would shade down, then a little bit of a turn here, and then shade down. So there's a pretty good picture of our graph. Okay, pretty good picture. Now, let's continue on. Does a diver with a depth and time of 80 and 50 need to decompress? Well, let's see. Here's his depth, I'll put a D here. Here's his time, I'll put a T here. Does he need to decompress? Well, let's see. His depth is 80, so I'm going to use this model right here, because I use this model when my depth is from 60 to 90 feet, and his depth was 80. So I use this model here. So here's my D right here. What do I put in for my depth? 80. 120 minus 80 is 40. So the time this guy had to spend was 40 minutes or less. How much time did he stay? 50. He stayed too long. He went 10 minutes over, so there's no way he can shoot right to the top of the surface, okay? He's going to have to decompress. Go up slowly, go up slowly, go up slowly, go up slowly, and decompress. Alright, let's try the next question they ask us now. How about a diver with a depth and time of 100, comma 20? Here's my depth, here's my time. Well, let's say my depth is 100, so I'm going to use this model here, because we use this model when the depths are between 90 and 130, and our depth is 100. So where my D is right here, I'm going to put 100, because that's the depth I'm checking out. Well, 1 half times 100 is 50, so 75 minus 50 is 25. So the time that you were allowed to stay at a depth of 100 is 25 minutes or less. How long did you stay? 20 minutes. So you're good. You're totally fine. You can go ahead and shoot right up to the top of the water and not worry about decompressing. Okay. So these two problems here give us a little bit of an insight as to what the problems are going to be like in your homework tonight. Like I've done before with word problems, I would really strongly recommend that you use that you really focus on your homework. Take notes like you've done, but most of your learning when it comes to word problems will take place during your homework. Okay. Hope this has been a help. Don't hesitate to call or email if you have any questions.